Hello students, welcome to chemistry classes. Today we are going to discuss group-wise electronic configuration and classification of elements. So far we discussed various methods of identifying the elements, arrangement of elements, their electronic configurations. Now, group-wise electronic configuration. We know that what are groups? The vertical columns in the periodic table are commonly said to be groups. Columns are groups. There are 18 groups. 18 groups in the periodic table. It is numbered from 1 to 18. 1 to 18. Electronic configuration, how electronic configuration varies in the groups. For example, consider the group 1 elements: hydrogen, lithium, sodium, potassium, rubidium, cesium, francium. We know that atomic number of hydrogen 1, electronic configuration 1s1. Lithium 1 atomic number 3, 1s2, 2s1. Or simply write the electronic configuration of helium 2s1. Similarly, sodium atomic number 11, 1s2, 2s2, 2p6, 3s1. Configuration of neon 3s1. All these elements having similar electronic configurations by varying the principal quantum number alone or period number alone. Look at this electronic configuration: hydrogen 1s1 configuration, lithium 2s1 configuration, sodium 4s1 configuration, 3s1 configuration, potassium 4s1, rubidium 5s1, cesium 6s1 and francium 7s1. Or it is written like this: potassium atomic number 19, configuration of argon, argon atomic number 18, 4s1. Then rubidium, cesium and francium. Configuration of krypton 5s1, xenon 6s1, radon 7s1. So this is the group wise electronic configuration of these elements. So any group, it is similar variation is occurs. Any group, the similar variation is occurs. Suppose we are writing the electronic configuration of group 2 elements. These 2 elements having ns2, 2 outer electronic configuration, all the elements having ns2 configuration. So this is all about the group wise electronic configuration of elements. Now, how these elements are further classified? These elements are further classified depends upon the subsidiary quantum number or sub energy levels. I already told you the 4 different sub energy levels are there: S, P, D and F. Here also these elements are also classified as S block elements, P block elements, D block elements and F block elements. F block elements. Now a question arises: what is the exact position of hydrogen in the periodic table? Hydrogen, there will be no exact position is arises because it is a first element in the periodic table, electronic configuration 1s1. Suppose this hydrogen lost 1 electron from the valence shell, it attained the configuration of H+. Hence it present or it may be present in the group 1 elements. In another way, hydrogen gain 1 electron. This is loss of electron. Hydrogen gain 1 electron, H minus. So it shows the electronic configuration of 1s2, H minus. the tendency to form the halide ions Cl minus, F minus, Cl minus, Br minus, I minus. Suppose hydrogen gain one electron means it is present in the, it may be present in the halogen family. So it lost one electron or it gain one electron. Therefore, the center part of the periodic table, hydrogen is present. Hydrogen atomic number 1, mass number 1.008. How these elements are classified? I already told you S block elements, P block elements, D block element and F block elements. The group number 1 is called 1 and 2. 1 and 2 are called S block elements. Group number 1 and 2 are called S block elements. Group number 3 to 12. Group number 3 to 12 are called D block elements. D block elements. Group number 13 to 18 are called F block, P block elements. This is P block elements. Two group of elements present in the bottom of the periodic table are called F block elements. F block elements. Now we are going to discuss the detailed study of what are S block elements, D block elements, P block elements and F block elements. So what are S block elements? Group number 1 and 2 are called as S block elements. Group number 1 is called as alkali metals. This group number 1 is called alkali metals. Group number 2 is called alkaline earth metals. Alkali metals, alkaline earth metals. These are present in the extreme beginning of the periodic table. They are highly reactive metals. All are highly reactive. And it shows or it forms colored ions. Some of the elements form colored ions and very reactive metals, and therefore readily lose one electron from their valence shell. Especially alkali metal consists of only one electron present in the valence shell. These elements easily lose the electron from the valence shell and it attains the positive charge. All these elements, lithium plus, sodium plus, potassium plus, rubidium plus, cesium plus and francium plus. Therefore, the general electronic configuration of this group element is NS1. Why it is called as alkali metals? Alkali means plant ashes. Alkali means plant ashes. Some of the elements are identified from the plant ashes. Therefore, they are referred to as alkali metals. The general electronic configuration NS1. Group number 2 are called alkaline earth metals. Alkaline earth metals. Group number 2. Beryllium, magnesium, calcium, strontium, barium and radium. Beryllium, magnesium, calcium, strontium, barium and radium. Here the francium is the radioactive element. Here the radium is the radioactive element. Radium is a radioactive core. From the core of radium, majority of other radioactive elements are identified or synthesized. Beryllium is relatively rare abundant present in the earth crust. Magnesium, calcium, strontium, barium are somewhat present in the earth crust also. Why these elements are called as alkaline earth metals? These elements consist of 2 electrons present in their valence shell. Suppose we are taking magnesium as an example. Magnesium atomic number 12, electronic configuration 1s2, 2s2, 2p6, 3s2. These two electrons, valence electrons, are easily lost. It attained the configuration of Mg2 plus. Mg2 plus. They are readily form hydroxides. Readily form hydroxides. Therefore, they are referred to as alkaline earth metals. The general electronic configuration of these group members are Ns2 configuration. Ns2. These elements are, majority of the elements are useful in industrial process, especially cesium is the lightest element, is highly useful in photovoltaic cell. Photovoltaic cell. Radioactive element of radium is highly useful in radiation chemistry or the treatment of cancer. And calcium, magnesium. Magnesium is present in chlorophyll. Calcium is also used for human being as well as animal kingdoms. So this is all about the S block elements. Suppose question may ask in the examination, you can write some points about the S block elements. What are the elements present in the concerned group? General electronic configuration, nature of the elements. These are highly reactive metals. Highly reactive metals. And ionization energy, they show slow ionization energy. I explain later what is ionization energy. It shows less ionization energies. Now, P block elements. What are P block elements? The elements present in the group number 13 to group number 18. Group number 13 to group number 18 are called as P block elements. S block elements and P block elements, collectively known as representative elements or main group elements. S block elements and P block elements are collectively or together known as representative elements or main group elements. Group number 13. Group number 13, boron family. Boron, aluminium, gallium, indium and thallium. Carbon family, nitrogen family, oxygen family, halogen family, noble gases, helium, neon, argon, krypton, xenon, radon and oganesson, fluorine, chlorine, bromine, iodine and astatine. Oxygen, sulfur, selenium, tellurium, polonium. Nitrogen, phosphorus, arsenic, stibbium, antimony, bismuth. Carbon, silica, germanium, stannum, plumbum, tin, lead. So these are the elements present in the P block. Boron family, group number 13 is called boron family, carbon family, nitrogen family, oxygen family, halogen family and noble gases. Group number 18 is called as noble gases or rare gases or inert gases or zero group elements. Zero group elements. Relatively rare, abundant in the atmospheric air. Noble gases are highly reactive because of their electronic configuration. These elements shows Ns2, Nb6 electronic configuration. Ns2, helium 1s2, neon 1s2, 2s2, 2p6. Similarly, all these elements shows Ns2, Nb6 electronic configuration. They are chemically inert. These elements does not lose one electron from the valence shell. Therefore, it shows high ionization energy. Very difficult to remove an electron from the valence shell. These elements does not add one electron to their valence shell. Therefore, the electron affinity of these elements are zero. Noble gases shows zero electron affinity. chemically inert due to their completely filled electronic configuration. Simple question asked in the examination point of view means why noble gases shows 0 electron gain enthalpy. It does not gain 1 electron to the valence shell. Why noble gases are inert? Why noble gases are inert? Noble gases are inert due to completely filled electronic configuration. Group number 17 is called halogens. Halo means salt. Gen means producers. Salt producers are called halogens. Look at this halogen family: fluorine, chlorine, bromine and iodine. Mostly we are using this, considering these 4 elements. Astatine is radioactive element. These elements combines with either alkali metals or alkaline earth metals to form a stable salt. For a compound, you know the table salt or the sodium chloride, common salt or Brindt solution, sodium chloride. How sodium chloride is formed in lower classes, your detailed study about formation of formation of this ionic compound by complete transfer of 1 electron from one atom to another atom. Salt producers, therefore they are referred to as halogens. This oxygen family is called as chalcogens. Chalcogens. Why they are called as chalcogens? Chalcogens means ore producers or metal producers. Majority of the ores exist in the form of either oxide or sulfide, selenide or telluride. You remember the ore of zinc blend exists in the form of zinc sulfide. Zinc oxide exists in the form of oxide. So similarly, majority of the ores exist in the form of oxide, sulfide, selenide or telluride. Therefore, they are called as chalcogens. Look at this last element, polonium. Polonium is a radioactive element. Polonium was discovered by the scientist Madam Marie Curie. Her home country is Poland. Therefore, it is referred to as polonium. Nitrogen family, group number 15. Nitrogen is family is called pnictogens. Nitrogen, phosphorus, arsenic, stibbium, Sp, antimony, bismuth. And carbon family, tetrogens. Tetrogens are called carbon family. Carbon, silica, germanium, stannum, tin and plumbum, lead. This boron family is called isohagens, boron family, carbon family, nitrogen family and oxygen family. Each compounds or each family shows an electronic configuration. This family shows ns2np1, ns2np2, ns2np3, ns2np4, ns2np5, ns2np6. This p block elements includes metals, non-metals and semi-metals. Metals, this borderline. In between the borderline, these elements exist in the form of this is non-metal gases and some liquids. This row or these columns, these elements are metallic state. These borderline elements are called metalloids or semi-metals. Metalloids or semi-metals. What are metalloids? Metalloids shows both metallic character as well as non-metallic characters. These elements, especially silica, germanium and this stibbium, this borderline metal shows both metallic character as well as non-metallic character. Therefore, they are called as metalloids. These elements shows higher ionization energy. The special character of this p block element is inert pair effect. Inert pair effect. Inert pair effect. What is inert pair effect? The general electronic configuration ns2 nb1 to 6. This is a general electronic configuration. The pair of electron present in the s orbital does not involve the covalent bond formation. Covalent bond formation, because most of the elements, most of the p block elements are covalent in nature. The covalent bond formation, the two electrons are not involved. Therefore, pair, two electrons, inert, not involve the bond formation. Hence, this is called inert pair effect. This is all about the p block elements. Suppose in the examination point of view, the question may ask like this, give short note on p block elements means first you write the electronic configuration, general electronic configuration ns2 nb 1 to 6. It includes metals, non-metals and semi-metal. Give examples. Metals, boron, aluminum, gallium, indiums are metals. Semi-metals, silicon, germanium are semi-metals. These are all gallium, neon, argon, krypton, xenon are non-metals. Non-metals. And explain each family, boron family, carbon family, nitrogen family, oxygen family, halogen family and inert gases and their special names. This is all about the p block elements. Now, d block elements, the in between highly reactive metals and the less reactive, the p block elements, a group of elements present in the middle part of the periodic table are called d block elements. The d block elements are otherwise known as transition elements. Transition elements. Why they are called as transition elements? They form a bridge between highly reactive metals and less reactive non-metallic elements of periodic p block elements. Therefore, they are called as transition elements. They are all reactive metals. Reactive metals. Compounds of these metals are act as catalyst. They shows variable oxidation state and they form colored ions. Except mercury, all are exist in the form of solid state. They are act as a very good conductor of heat and electricity because of the presence of valence shell electrons. First of all, the first transition series. Look at this: scandium, titanium, vanadium, chromium, manganese, iron, cobalt, nickel, copper and zinc. Atomic number 21 to atomic number 30. First transition elements. In this transition elements, the electrons are gradually enter into d orbitals. Therefore, the general electronic configuration of this d block element is n-1 d1 to 10, ns1 to 2. What is the general electronic configuration of d block elements? n-1 d1 to 10, ns1 to 2. Why it is n-1? Because the electrons, added electrons enter into penultimate cell. What is penultimate cell? The cell before the last cell or the valence cell. The cell before the valence cell is called penultimate cell. Nth cell, n-1th cell. Electrons are enter into the n-1th cell. Therefore, n-1 d1 to 10. Gradually electrons are enters 1 to 10. Suppose we are writing the electronic configuration of scandium. Scandium atomic number 21. Configuration of argon 3d1 4s2. What is the atomic number of argon? 18. 18, 19 plus 2, 21. Similarly, d1 to 10 electrons are gradually filled. So, I told you these are reactive metals very good conductors of heat and electricity, malleable and ductile. It shows sonorous and lustrous properties. Sonorous and lustrous. Sonorous and lustrous. Sonorous bell sound. Lustrous shining capacity. Most of these elements shows. And most of the elements form colored ions. Most of the elements and their compounds are act as a catalyst. It shows variable oxidation state. Look at the last or the group 12 elements, zinc, cadmium and mercury. These three elements shows zinc, cadmium and mercury. Configuration of argon 3d10 porous 2. Configuration of krypton 4d10 5s2. Configuration of xenon 5d10 6s2. Look at this electronic configuration of these elements. Zinc, cadmium, mercury shows completely filled electronic configuration. These elements not included in the periodic table of D block. Why these elements are not included, but these elements are included? Why these elements are not included? Because this element shows completely filled configuration. There will be no tendency to lose the electron present in the D subcell. D subcell electrons mostly does not involve the bond formation, but it resemblance with certain respects they are included in the D block elements. Zinc, cadmium, mercury. We are not expected, this element shows there is not expected their periodicity. It shows low melting and boiling point. Low melting and boiling point. Why this shows low melting and boiling? These are the questions asked in the examination point of view. Why zinc, cadmium and mercury shows low melting and boiling point? Because of their completely filled configuration. This element does not form any colored ions. Why zinc, cadmium, mercury does not form any colored ions? This also the same reason, because of their completely filled configuration. There will be no thermal excitation or visible excitation occurs. Therefore, these elements are colorless in nature. So, the general electronic, these are about the simple forms of the transition elements. And finally, two group of elements present in the bottom of the periodic table are called F block elements. F block elements. Cerium 2. Lutetium, cerium atomic number 58 to lutetium atomic number 71, two group of elements, and this is lanthanides and actinides. The electrons enter into inner D subcell. Here also one question asked in the examination. F block elements are called as inner transition elements. Why they are called as inner transition elements? They form separate transition series within the transition elements. Within the transition elements, look at this configuration here. One element called lanthanum, atomic number 56. The continuation of lanthanum is 57, 58 to 71. 14 elements are present in the separate series. Therefore, they are called as lanthanides. Similarly, the electrons enter into 5F block elements, actinium to lawrencium. Here actinium, here lawrencium, lawrencium. These concepts are detailed studied in class 12 chemistry. Okay. So, lanthanides and actinides. Suppose the electrons are enter into the 4F orbitals are called lanthanides. 5F orbitals are called actinides. 5F orbitals are called actinides. Look at these elements. Actinides, atomic number uranium, atomic number 92. After that, the elements are synthesized in the laboratory. These elements are called as transuranium elements. All are exist in the form of nanogram levels. And most of the elements are radioactive in nature. Half-life periods are very less. We are not easily studied the entire chemical properties of these elements. So trans-uranium elements. The general electronic configuration is N minus 2, F 1 to 14, N minus 1, D 0 to 2, Ns 1 to 2. Here the electrons are entered into the 4f orbital. The general electronic configuration of this lanthanides. So lanthanides, two group of elements present in the bottom of the periodic table. Lanthanoids, 4f block elements are called lanthanoids, 5f block elements are called actinoids. Most of the elements are prepared in the laboratory and their abundance are very less. Most are the elements are radioactive in nature. So these are about the F block elements. Now you clearly learn about this classification of elements: S block elements, P block elements, D block elements and F block elements. You go through the textbook and study very well. Thank you.